In an experiment on photoelectric effect, the slope of the cutoff voltage versus frequency of incident light is found to be 4.12 into 10 power minus 15 volts second. Calculate the value of Planck constant. So, photoelectric equation given by Einstein is h nu equal to h nu 0 plus EV0, where V is stopping voltage. So we can write this equation in terms of h nu. So it will become EV0 equal to h nu minus, this is work function, so we can write it W0, or B0 equals h nu upon E minus W0 upon E. Here, h upon E will be the slope because this is of the form y equal to mx plus c. Here, y-intercept will be minus W0 upon E and slope will be h upon E. So slope equal to h upon E. If we represent the same thing in graph, so we can say that graph will be like this. So this value will correspond to minus W0 upon E. This is nu 0. This axis represents nu and this axis represents voltage. So here slope is h upon E. Now in our question, h upon E is given as 4.12 into 10 to the power minus 15. So from where h equal to 4.12 into 10 to the power minus 15 times electronic charge 1.6 into 10 to the power minus 19, and this will give 6.6 into 10 to the power minus 34 joule second, which is value of Planck constant. Now let's go to next question. The photoelectric cutoff voltage in a certain experiment is 1.5 volt. It means V0 is given as 1.5 volt, and we have to find out maximum kinetic energy. And we know that kinetic energy of photoelectron is equal to electronic charge times V0. So 1.6 into 10 to the power minus 19 times 1.5, that will give 2.4 times 10 to the power minus 19 joule. An electron, an alpha particle, and a proton have the same kinetic energy. Which of these particles has the shortest de Broglie wavelength? So lambda is given by h upon p, and p equal to root 2m into kinetic energy. If you remember, as I told you earlier, 1 by 2 mb square is equal to kinetic energy, and we divide and multiply by m, so it becomes m square v square divided by 2m equal to k, and mb equal to t, so p square equal to 2mk, from where we get p equal to root 2mk. So lambda will be h upon root 2mk. Here kinetic energy is same, so only it is the mass that decides the ratio of the wavelength. So we can say lambda electron to lambda alpha to lambda proton will be equal to 1 upon root mass of electron is to root of mass of alpha is to root of mass of proton. We know that mass of electron is the least, mass of proton is less than mass of alpha particles. So here, if mass will be more, then lambda will be less. So we can say that lambda alpha will be the shortest. As it is clear, lambda e corresponds to 1 upon root me, and me has less value, very less value, and mp has less value than m alpha. So definitely Here, this term will be the least. A particle is moving 3 times as fast as an electron. So velocity of particle equal to 3 times velocity of electron. The ratio of the de Broglie wavelength of the particle, so we can say lambda upon to that of electron, lambda electron is 1.813 into 10 to the power minus 4. Calculate the particle's mass and identify the particle. So here we can write formula lambda equal to h upon mv. So we can generalize it. Lambda of particle divided by lambda of electron will be h upon mass of particle into velocity of particle times h upon mass of electron into velocity of electron. So here lambda upon lambda E is given as 1.813 into 10 to the power minus 4. And here this term will cancel out. And we are given VE here, V equal to 3 VE. So, and ME we know 9.1 into 10 to the power minus 31. And we write V as it is, and M times, in place of V, we write 3 VE. So V will cancel out. And now we will get M equal to 9.1 into 10 to the power minus 31 divided by 3 into 1.813 multiplied by 10 to the power minus 4. So if we evaluate it, it will come out to be 1.675 into 10 to the power minus 27 kg. And this could be proton or neutron. What is the de Broglie wavelength associated with an electron accelerated through a potential difference of 100 volt? So formula for de Broglie wavelength associated with an electron is given by 12.3 angstrom divided by root V. So here voltage is given as 100. So 112.3 into 10 to the power minus 10 divided by root 100. So root 100 will give 10. So this will become 12.3 into 10 to the power minus 10 divided by 10. So this will become 1.23 into 10 to the power minus 10 meter, or 1.23 angstrom, which is our answer. Thank you for watching.